So now let us have a look at what happens if you have downwelling favorable winds. Okay, again, here it shows the simulation results after 5 days of coastal winds blowing along the shore, such that you have an onshore Ekman transport. The top panel, let me activate the laser. Yeah, here we are. The top image shows you the density field. Blue is lighter near surface water in this simulation. You can see that it has been moved onshore and downwelled to some depth. Okay, you can see the downwelling effect, pushing water against the coast and downward. The second panel shows you the onshore offshore velocity component. Negative means onshore, so this is the Ekman, surface Ekman layer moving water towards the coast, and offshore in the bottom Ekman layer. Okay, these are the surface and bottom Ekman layers not overlapping. You can see that they are separate. Near the coast, there is a shutdown of this simulation. Green means actually 0. You can see here on the scale on the right, 0 is the green. So green means there's a shutdown. Whatever happens here actually stays in this zone. It's not moved much around. This is different to coastal upwelling. You can have a look at the previous slide. There's also a coastal jet developing. Okay? It's called the Downwelling Jet. And in difference to the upwelling jet, this is the Longshore Flow. It's up to a meter per second in this simulation. Actually reaches close to the seafloor and creates a very strong frictional stress with the seabed. We look at the stress in a second. First of all, what you see also is this last panel shows you it's an estimate of what happens in the water column. It is a measure of very strong mixing happening in nearshore water. Okay, this is a measure, you get very strong vertical mixing. And so now what happens near the seabed is, in due course of this downwelling event, there's a very strong bed shear stress developing, and starting first near the coast and then moving offshore. Okay, and this bed shear stress is so energetic. In this simulation, it's 0.4 pascals. It's energetic enough to actually erode bed sediment and to release nutrients from the bentos. Okay? So this is the idea, that wind-driven coastal downwelling can actually release the nutrients from the seafloor.